So let's take a look at this question here. One of the skills I want you to have when taking your final exam is to look at your four multiple choice options and try to differentiate them. Say, what's different between these multiple choice options? So as we look at these four multiple choice options, you should notice that all of them are parabolas opening up with basically the same shape. But the big difference between all four is where the vertex is at, which quadrant the vertex is in. So that's really at the heart of things. What we want to figure out is where is the vertex of this parabola. So in order to do that, we need to find the x value of the vertex. So you are going to have to remember a few formulas for this final. One of which being the x value of the vertex is the opposite of b over 2a. So in terms of this problem, the b was 8, so we're going to put the opposite of 8. And the a is 2, so 2 times 2. This gives us negative 8 over 4, or that the x value of the vertex is negative 2. Now, once you get one piece of information that helps you to cross things out, I usually try to say, if I know that the x value of the vertex is negative 2, then my answer can't be B nor D, because both of those have positive x values of the vertex. So now let's look at the y value of the vertex, and I want to talk about two different ways to differentiate between answer A and answer C. And one of the reasons I want to talk about two different ways of differentiating between them is so that you have one way that you can do the problem and one way that you can check your answer. So that's a really good thing to have anytime in a math test, is to be able to do the problem but then check it using a different method and say, if my answers match up between both, then I can be pretty confident with my answer. So let's take a look. Let's first of all do this kind of our normal way, is to say the y value of the vertex is to plug that x value back in. Now for this particular problem, one of the things I don't like about this is how many ways we could make a sign mistake. So I'm going to plug negative 2 in for the x. I'm going to plug negative 2 in for the x again. And so the y value of the vertex is going to come from, say, negative 2 squared is positive 4. So that's an area where we can make a sign mistake. We've got to be careful. 8 times negative 2 is negative 16 again, an area for a sign mistake, so be careful. So 2 times 4 is 8. 8 minus 16 is negative 8, another spot for a sign mistake. And negative 8 plus 11 is positive 3. Again, a place for a sign mistake. So we should be seeing that the vertex is at negative 2, 3, which tells me that A is the correct answer and C is incorrect. Now, I want to talk about a different way that we could verify that A is the correct answer. And this is a way that we talked briefly about earlier in the class, but not as it pertained to this kind of problem. One of the things we talked about earlier in the class that would make this pretty straightforward and simple was the discriminant. The discriminant, if you remember, was this way that we looked at determining whether there were two real answers or two non-real answers or one real answer to a quadratic equation. And this was really just by looking at what's underneath the radical in the quadratic equation. So what I want to look at then is I want to look at saying, well, what if the y value of this equation were 0? So what if I was solving 0 equals 2x squared plus 8x plus 11? Graphically, what it means to have your y value be 0 is where do we cross through the x-axis at? Because that's where your y value is 0. So solving that equation I have written at the bottom would be the same thing as saying, at what points does my graph cross through the x-axis? Now what the discriminant told us is the discriminant said, just look at b squared minus 4ac. So in our problem that would be 8 squared minus 4 times 2 times 11, or 64 minus 88. And the cool thing about this is that we don't really care what this value is. All we care about is that it's negative, which means as you solve the quadratic formula, and you have a negative underneath the radical, your answers to the quadratic equation are not real. So there are not any real solutions to this equation. In terms of the graph, what this tells us is that we don't actually have any x-intercepts. We don't actually cross through the x-axis, which helps us to verify that the answer is in fact A.